Hello, welcome back. We have already covered single producer, single consumer, and multiple producer and single consumer. I hope you had fun in those videos. If you have any questions, you can always write in the comment section or ask me in the chat directly. Now, it's time for a big one. Multiple producer and a multiple consumer. We call it MPMC. This is a common concurrency pattern if you want to reach true parallelism. So let's tune into our smaller video where we can have a look how does this pattern, like the small pattern looks. So where does this video lies? So we have this one, it's a video. So if we turn on the video, you will see that we have multiple producers and two consumers here. So they publish everything into the channel, and whichever basically the consumer is free to consume it, it will consume. Okay, now we will start to write the code for it. The code is very similar to the ones which we have already been writing for the other patterns, but it will get a bit different towards the end. So stay tuned. I'm telling you, it's exactly not the same, and it won't work with the standard STD that we are using it so far. So to start with, I'm going to start the same with the MPSC. We use STD thread again, and the last thing you need STD time, and then we use to go have duration. Okay, we start with the main. We create let tx comma rx is equal to mpsc channel. Now here the code get bit different from now what we are going to create. We have to create multiple producers. To create multiple producers, we have to have my plan is to create 3. So basically what I'm going to do here is that I'm going to use my curly brackets, and we are going to create 3 producers. Basically we are going to spawn 3 threads. To have 3 producers, you need 3 transmitters. So we are going to clone our tx like we did for 2 producers, but here I'm writing inside the loop so that every producer gets its own transmitter. So the last point is to use the thread.spawn and then move. So everything is moved inside the thread, and then for jn1 : equal to 3, and let message is equal to format. So this is how we are creating a message. Producer brackets which producers and what is the value that it produced, and that would be the producer will be I, and the value it is producing it is j, and then we are going to use our tx underscore clone dot send, and what our message is, not the message, the value of j, and basically we are going to let our thread for sleep sometime. So thread dot sleep for sleep duration for millis, and let's say 200. Right, this is how we have created our multiple producers. For you it is very simple. Now you will think we can also do the same for multiple consumer, right? Actually your thought is not bad. Result may be used, the result may be error. Yes, because as we have used, we have to also use the unwrap function for it, and then this is fine. You can also send the whole message here instead of just basically send. You can also send the string. You don't need to always send basically the integer. You can send everything via tx.clone. So we are currently sending a message, right? Now we need multiple consumer. We were kind of writing the same code, but we will write it inside a for loop this time. So what we will do is like 0:2. So we are going to create like 2 consumer, the 1 and a 2, and here you will just write the things which you normally do is that you will try to clone the receiver, because now you have 2 consumers which are using the same receiver queue, right? So what you do is that you write rx.clone is equal to rx.clone, and what you want to do is that same thing, you write the while loop, let OK of value is equal to what we do is that we do is the rx clone dot receive, dot receive recv, and you might have figured by now that there is something wrong because I am not getting any help from Rust analyzer, and usually it doesn't happen. So whenever I try to write something, it helps me, right? So let's say consumer this got this, what is the value it got, and then we say k is a consumer and the value it got is the value, right? One thing which I forgot is that everything which should be written in the thread, so I have to move here everything in the thread, and then I need to close this out as well here like this. So, and then I need to also close this out, and then basically a semicolon. So this is basically finish our spend, but you see there's an error in the clone method. The issue is that MPSC as a name suggests only supports single consumer. It doesn't support multiple consumer. Now, there are two ways to solve this. One, we can use arc.mutex. Basically, arc is like kind of a shared pointer if you compare it to other languages, or another crate called Crossbeam. I want to introduce Crossbeam because it's a really powerful crate, and if you want to implement Rust properly, why not use Crossbeam right now? So to use Crossbeam, first you need to do cargo add Crossbeam, which is very simple and you can do it really on your own. The other thing is to use, so I've already done that. If you can go to cargo.ml, you will see that the Crossbeam already added here, and I'm using channel. Other thing to do here is that you have to remove this and use channel : unbounded, right? I'm using all the channel, and you don't need to change anything. Last thing is that, as I told you, you need to join all the threads. Otherwise, your main function will finish much earlier than your thread finishes. As currently we don't have anything called rx.clone outside this for loop, the variable doesn't exist. So what we are going to do is very simple. We are going to basically let our main function sleep. So as main function is also a thread, we do main function sleep duration from millis. Let's say not millis, actually we need to run it from seconds, and let's say 10. So our main function will sleep for 10 seconds, and then whenever it finishes, we see our message called hello world, right? Let's view our terminal, and we do CLS for the last issue, and we do cargo run. So let's see, it says unwanted import. It's okay, we can remove this. And we have also did a mistake called rx.clone. Here it should be a semicolon. I put like a normal colon. Okay, so we can use all CLS here. We clear the screen, and then we run again cargo.run. It compiled, and now everything is working fine. As the consumer and the producer got finished earlier, basically our main thread will still wait for 10 seconds to print the hello world. But you see the main thread finished. Now we got the hello world, and you see the program execution has ended. Just to understand this, let's see. Consumer 1 got producer 0 produced 1. Consumer 1 got again producer 1, 1. Consumer 0 got producer 2, 1. So basically it doesn't matter who is getting what, but it know that whatever you are sending is getting consumed. So again, consumer 1. So basically you see producer 0 produced 1 got consumed. Producer 0 produced 2 got consumed. Producer 0 produced 3 got consumed. And sometimes it is got producers like consumed by consumer 0, consumer 1. So this is how your multiple producer and multiple consumer work. Remember, this is a synchronization mechanism. The program looks easy because we are using channels from the crates called Crossbeam and MPSC. Otherwise, if you want to implement it on your own, the whole channel itself, you have to use mutexes, because channel is nothing but a queue in which basically your multiple producer are writing to the queue and your multiple consumer are reading from the queue. And every time you read and write, you need a mutex, because otherwise you cannot access the queue. So this is how your multiple producers and multiple consumer works. And now, since we have completed this, remember, this is one of the common pattern which is done to achieve the true parallelism. The Crossbeam channels, both sender and receivers are clonable, and that's why we are using the Crossbeam rather than using the MPSC. In the further project, we are going to basically create more a complicated project using thread called like something called a thread pool or something. But to get to there, don't forget to like, subscribe for more Rust concurrency deep dives. Thank you so much and have a nice day.